Well, thank you for having us over here. We're excited to present our results from wind turbine control. And we've spent lots of time on this project. These two are in energy engineering, and we've taken some classes on wind turbine control. So we would like to address one very big problem with wind turbines. As you can see from this GIF, at high velocities, the blades of the windmill aren't designed to carry that much speed, and so it bends the blades back and it can destroy the whole wind turbine. And so we wanted to address this problem, and there's a couple different ways that we can do it. And engineers have come up with brakes for wind turbines, so at those high speeds it turns some of that high power into a braking system to slow it down. And the other way is to actually turn the turbine out of the wind and change the pitch of the wind turbine, and that way it would slow it down. And so that's what we focused on, was the actual pitch in the yaw. We didn't implement the brake, but we thought that the pitch in the yaw would be very beneficial.
Yes, and most wind turbines have always done the yaw. It's more of a recent thing where they started developing where they can actually change the pitch, which allows you to improve the performance of the wind turbine over a wider range of wind speeds. And so part of this we had in our equation was we didn't fully model the generator in the wind turbine. We just assumed it to be a constant, even though it is technically a dynamic thing, changes with position of the rotation. And so we just modeled it as a function of the yaw, which is on the equation as theta as phi, and then beta as the pitch, and wind velocity is the W. And as these things changed, we then linearized it so that we could just see the individual functions or individual parts of the angular velocity of the wind turbine itself.
So our controller had a unique challenge because the pitch in the yaw had both a direct and indirect factor in the equation. And so right here we highlighted our controller portion, and so you can see that the pitch control and the yaw control both directly have a direct effect, and then the transfer function of the model that's kind of outside of the box, that is an aggregate model function that takes into consideration the wind and then also the subtle changes of the pitch and the yaw. And so we had two controllers that were affecting three model functions. The rest of the sheet that you see, this is the different constants that we had, and then also because of this relationship with the wind variations and the pitch and yaw variations, we had to use an iterator in order to fully utilize the different dynamics and physics that are in this wind turbine.
Yeah, the iterator's there so we can separate the angular velocity out of the torque that's applied to the windmill, since they're dependent on each other. So we used the iterator for that. And then part of the thing was just a actual feed-forward controller for the yaw, based off if we have a certain wind speed, it should be a certain angle turned out of the wind, or directly into the wind based on the wind speed. And also beta is applied in a similar way, where we pulled it from an ideal model to compare it with the actual as to where it should go to.
So using that, we also came up with a function calculating the ideal power and the actual power of the windmill. We have a picture of this next where you can see our results. So the blue is the wind velocity, and the green is the actual power, and the purple is the ideal power that we calculated out. And we made it so that the ideal power would chop off at 6 megawatts because that's what the windmill is designed for. So that's where you'd normally want a brake installed into the windmill. So we saw at the very end this flaw that we should have accounted for at the very beginning or started to control. But everything else looks very good. We optimized the system so that we'd get the most power that we could out of the system. And and it looked great overall with the controller and everything we implemented.
So in the future we would add in the brake and hopefully we would get it to level out at that 6 megawatt optimized point.